Hi, everyone, and welcome to NDC Sydney 2024. I hope you had a really good time so far. And today I'm going to talk about harmonious dance of EF Core and SQL Server. And what I wanted to achieve here is to give you some of the knowledge that quite a few people already know, but they're not quite aware of how does that impact the application or EF Core, or what actually is happening behind the scenes. And I'm going to open up a little bit about that. And I'm also going to show you a few things that I really love, which is logging. And I'm going to show you some indexing and a few more other things. I am Jernej Kavka, and I know this is very easy to pronounce, but you can call me JK as well. You can follow me in all of those socials. I am a host at Global AI, the podcast. Funnily enough, we actually have a panel happening in, I believe, 2 hours. We're going to talk about our podcast. And I'm predominantly a .NET and EF Core developer. So I work with EF Core every day, and sadly also with EF6. And that .NET framework. You might also have seen I'm a Microsoft AI MVP, and I like to be like the AI generalist that tries to look at problems and find ways of solving them, not with specific technologies, but trying to think about what would be a good solution and then try to find the right technology. All right. So if you're interested in rewards, you can download this app. And at the end, I'm going to show you another QR code where you can get the points. If you want to re-download the app later, I can show you the QR code later. And this talk is kind of not kind of successor. It's but works really well with my previous talk, Common Mistakes in EF Core, where I talk about specifically for EF Core what the mistakes that I have seen in production, in other people's source codes, and sometimes also the mistakes I've done myself. But those are mostly focused on EF Core. Today, we're going to focus on how EF Core works with SQL Server. And why specifically SQL Server? SQL Server is the most commonly used database with EF Core. All right, so first off, we're going to start off with the logs. I'm going to show you some how to set up telemetry. And then we're going to switch to the magic of SQL. I'm going to show you a little bit how SQL is generated behind the scenes and how a few little changes ends up with quite a few weird select statements. Have anyone investigated the generated EF Core queries? We have a few hands. Have any of you looked at them and say, why is it having so many select statements and froms and braces and stuff like that? Well, hopefully I'll be able to demystify that a little bit today. And at the end, I'm going to show you how you can use indexing with EF Core, because this is one of the most underutilized features that we need to use as EF Core developers. EF Core will not magically solve our database problems, but we don't need to write raw SQL to solve them. All right, so who thinks logging is important? Almost everyone. That's good. So I'll just go real quick through. So why logging is important, at least for me? Well, first thing, I want to know what happened. Like, for instance, a web request crashed. Then I want to understand why it happened. For instance, imagine that something got locked up in the SQL database. So that's interesting, right? Now I understand what happened and why. But then I want to know when. Now, the reason why I want to know when is because did it happen at the peak time Or did it happen sometimes in the midnight when nobody is even supposed to be using the application, right? You look at the problem differently. So if it happens in a peak time, you might actually get different errors because there's so many operations going on. And this might be only a symptom of the real problem. So this is why it's important to know when. And lastly, you also want to know where it happened, usually in your code. So in this case, it was just invoice service and update logged invoice. So I know I need to know this is the place where I need to fix the problem. Now here I have an example of a telemetry trace, and don't look at anything else. But what is important here is this is the exception, right? That's what happened. It crashed. It happened on this time. This is why it happened. And this is roughly the location where it happened. And this is very important to know. Now, the issues sometimes that we have is that we don't get all of that when we're dealing with SQL and when we're dealing with EF Core. And this is where I'm going to show you how you can do that. So first off, what we want to do is we want to solve this problem in stages. So first, we want to have telemetry. We usually go for application insights, but open telemetry is becoming very, very good because it also supports application insights, but you can decide to use whatever else you want to use behind the scenes. You don't have to limit yourself to application insights. You can even do an on-prem solution if you like to. And the reason why you want to tackle telemetry is because this is what you get by default. This is a telemetry for SQL, and what we get is it happened. Now, if you have like 100 SQL statements happening in one request, you could potentially count how many of them happened and then try to reverse engineer to figure out where in the code that query might be. But that can take very long time. And if it's indeterministic, you might not be able to find what this query is. And this is the query that happened right before the crash. So it's quite important to know what that query is. So how do we solve this? Well, we can go to the open telemetry. We can install the open telemetry. There's a lot of instructions on how to do it. This one specifically for application insights. If you haven't tried open telemetry, I strongly encourage you to have a look into it, because especially if you combine it with Aspire, you get really, really awesome dashboards locally when you develop, and it's really awesome. So what happens is once you configure open telemetry, you get this. We get the SQL over here. So now you get a bit of an idea. Okay, we inserted something. So that's something, right? But it doesn't tell us, a lot. Like we might need a little bit more information. What if that query is not the problem? What is the queries before it? So what is the flow of that? What data are we trying to fetch logically? We're not interested in the exact data. Well, we are interested in queries in a logical sense. And what we can do, first off, is we can enable logging in EF Core. What this allows us to do is to be able to get queries inside your logger. So that allows you to have SQL queries. You see what's happening on your local machine. You don't have to deploy it to production or set up an entire Aspire setup, and you're able to get these SQL statements. What you can even do is you can have this enabled only for local development and then disable it for production if you worry about having too much information in your logs. And here is also, we have rules for better tracing if you're interested in that. And What is also interesting is Open Telemetry actually is going to give us an extension where we can add EF core tracing directly in Open Telemetry. And they're also adding console extension, which means that we no longer need to manually configure all of the stuff. So in the future, this is currently in preview. In the future, we might only need 2 steps. One is to configure the telemetry, and the next step, adding additional context in the code for your SQL queries, for the EF core queries. Now, what I mean by that is when we're trying to execute an EF query, we can add tag width. And what that tag width does, it adds that label over there into your SQL statement. So this is something you can observe in your SQL profiler. This is something your logs will have in. This is something when you analyze your SQL queries, you will have that. Now, if you make a unique label for every single SQL query, you'll be able to go to SQL Server, make top 10 requests that are the slowest, top 10 queries that are the slowest. Take this first line, copy, Control-Shift-F in Visual Studio, VS Code, or Rider, and find the exact query that is the worst offender. It may take you 5 seconds to find it. Now, if you have a very how many of you have spent a lot of time trying to look at the SQL query and try to figure out where that encode is? We have a few hands. I have one case where we spent it more than a day because we had a few queries that were very similar and they were different in just a few minor ways, and we just couldn't figure out which one of them is. With this, it took us 5 seconds. It just simplifies a lot of debugging. And when things go really bad, this can save your weekend. Like most of the issues that happened when a product succeeds. And all of a sudden, your application is under much higher load than usual. And then you have queries that misbehave. And the issue that I find a lot of times is everyone is panicking because they can see there's a query that is causing the problem, but there's too many parts of the code where it runs the similar query and they don't know which one is it. That's one of the problem is they don't know exactly how that particular link is generated into SQL, but the other one is if you have massive queries, because usually that happens with pretty big queries. It's not trivial to compare SQL with link. All right, but you know what? We can do better. Why would you want to write everything by hand? We have tag width call side. This was added in EF Core 6. And what this allows you to do is it just adds you a file path and the line number of that query. One thing to keep in mind, this here is generated based on when this method was called, not when the query was executed. This is something to keep in mind. But personally, I don't like this. And there's 2 reasons for it. One, if this is actively developed application, the queries might be moving around all the time. Like, you know, we are refactoring the class, making things simpler. So the line number might change all the time. And the other problem is this part here, the file path, that's going to change constantly as well. So now if I want to automate this part, I need to have a parser that tells me the one thing that I'm interested in. It's the way it executed, the class. Usually, in a lot of cases, we have quite unique names of the classes. So if you have the class name, you roughly know where this SQL query exists. So what I did instead, of course, I did my own thing. Now, actually, this is a bit of a lie because I did this in EF Core 2.2, way before we had the tag with call. What was it? A tag with call site. It's hard to remember. Instead, I created tag with context, which I think it's much easier to remember because we're tagging with context. We're trying to add some additional information to the queries. And what I did here is, here I have a label. You can optionally say, put nothing in it. And what it does, it automatically generates for you the class name, the method name, and whatever label you add. Now you have a very unique query. And the reason why you want the label is, imagine that you have more than one query in your method. Now, if you have like 4 queries that have the same name, you might be able to figure out which one it is. But if you just write a simple text over here, you know exactly which one it is. And there's also a hidden benefit to this. This is not quite a comment, but it can almost function like one. So this tells other developers what were your intentions. So here it was counting sales. So if somebody changes and this is no longer .count, and somebody looks at it, it says counting sales, but it fetches some invoices. What's going on? You can then look at the history and see what's going on. And then you might realize, hey, we've done all of these changes, but we haven't really updated our tags. We haven't really updated the intentions behind our code. So we might want to refactor this part to be still true with our original intentions or update it to our current intentions. So if you're interested in the extensions, there's going to be this link down below for SSW rules, tag with. And there's going to be a link to have this. It's a pretty simple thing. The interesting part here is this is supported in .NET Framework still. So it might not be the most .NET 8 optimized code, but it is highly compatible. And yeah, so now we have done these 3 stages of logging. Now you could also say telemetry, because OpenTelemetry is going to replace all of that very soon. So what happens once you manage to do all of that? What is the impact? Well, I can go to Application Insight and I can just go to a request, an HTTP request, and I can just say, yeah, we have this SQL over here, and yeah, it tries to get EMP any. Yeah, we roughly know what's going on here. And then it's like here, okay, it seems like we're fetching a client. Yeah, we're fetching a client. That's cool. And over here, we're getting a billable type. So now I don't have to have this code on the right, and I don't even have to read the SQL to understand what's going on. I can hide the SQL and still understand what this is supposed to do. And the biggest power of this is going to be in your SQL Server and your SQL profiler everywhere. There's a little caveat. Some of the SQL tools will actually crop out the information. I believe that if you're trying to do execution plan and other things, it may crop out the comments. So keep that in mind. But in most of the places, it will preserve the comments. All right. Now, how many of you found this very useful? Almost 3/4 of the room. That's really good. Now we're going to go to more interesting part. The first one was very useful, but now it's going to be very interesting. You know, how does EF Core generate prompts? Sorry, not prompts, SQL. Too many AI talks. But what I'm going to show you is, I'm going to show you a few things on the SQL end, and I'm going to show you similar link statements, and then how it changes through time. And specifically, I picked up joining because joining actually deviates from how we would write it the most, the query. And then in the end, I'm also going to add grouping, because I understand that grouping, when I ask people, what is the thing that you think that that isn't supported in EF Core, grouping is one of the things that comes up quite frequently. They said the group by doesn't work. And I'm going to show you why a lot of people think that. All right. So first, I'm going to start with SQL data representation. So how many of you are confident to say you know exactly what you're going to see? Not much confidence? You know, how many of you are confident what we're going to see here now? About half of the room. Well, we're getting a very simple table. We're just having ID, name, country. And it's a simple one row, simple representation, right? But for EF Core, it's kind of similar, but very different. Here we have a similar query. Over here, we are filtering by the author, and we're getting one out. We could do two lists to make it even more similar. So the only difference here is that here we have top one, because we are already expecting to have only one result. There cannot be, unless you configure the database incorrectly, there cannot be two authors with ID 1. So there's no point to do two lists. But SQL Server doesn't support first or default, right? That's the first difference. So this is why here we have top one, right? The SQL Server actually doesn't support just fetching one thing. You just get one row. Now, the other thing that is different here is we have a parameter, but this is mostly because this one is written manually. We can do this in SQL, but because we've written this manually, we just chose not to do so. But this is the difference, right? But the data is represented very differently. The data in EF Core, in .NET, is represented as an object, not as a flat table. And this is going to show a big difference once we're going to come to joining tables, and especially when we look at the grouping. Now, when we are joining tables in SQL, what we do is very simple left join, and we join it with posts. And here we have two additional posts. Now, what some might see interesting is that the author is duplicated. How many of you think this is normal? We have a few hands. Yeah, this is a normal consequence of one-to-many relationships. So when you join, this is normal. Now, the thing is, what if we join more stuff to it? Here I have joined with tags of post, and that tags is actually a many-to-many table. So multiple posts can have multiple different tags. Now, what is interesting here is this is fairly simple, right? Pretty straightforward. We have some duplicates, but in most of the cases, the speed of our SQL servers and the connection between the .NET application and SQL Server is fast enough, and SQL Server can stream the data fast enough that this isn't a problem most of the time. There are some cases where that is a problem, but the more joins you add, the more one-to-many relationships you have, the bigger the problem you might have on this end. The consequences of that is that even if SQL Server doesn't need to do a lot of work, EF Core might need to do a lot of work to actually go through all of that data. But now let's go to EF Core. So how EF Core deals with all of that. So here we have simple, just I added author, selected, similar query as before. Nothing too special, right? And now what I have done is I have added over here posts. So I have selected, so I'm only fetching the data from the database that I want. And over here, I said I also want to have posts. Now what happened here is EF Core, when you set up navigation properties, will understand, okay, you want data from that table. So it's going to join to that table for you. It's called implicit include. And for anyone wondering, I'll show explicit include at the end as well. But what you might be looking at, you might probably not look at the lower part, the one that I'm currently focusing at. You might actually be looking at this part and say, what is going on here? It's like, wouldn't here be just from author, right? That would make sense. But what's happening is I actually thought this is a problem. Why is this happening? And it took me a while to figure out, and a little bit of ChatGPT, to realize that what's happening over here is it tries to pre-filter this table. So what it tries to do is reduce the number of columns that the table has, the number of rows that the table it has, before it joins with the other table. Because if we look back to this original SQL, the filtering happens here. It doesn't happen over here. Now, SQL Server might optimize it so that it doesn't join more data than it needs to. But this, if you run it without optimization, joins everything, right? And it filters at the very end. Whereas what's happening over here, it filters ahead of time. So if you have a lot of data or a lot of columns, this actually might be more optimized than the one that we have written manually. So this is the context of why we have these weird queries over there, because all of that is generated. We don't need to write them by hand. So now we can do more complex query that do optimization behind the scenes. Now, what happens when we add text to the mix? Now, really cool thing about EF Core is we don't have to know that it's many-to-many relationships. We just say, hey, I just want to have text name. And it handles everything for us, which is really cool. But we end up with this. Now, what we have here is, if we look at very closely, you can see here, it uses the same strategy inside of here, and it joins, and then it creates another select statement over here to, reduce the size of the table before joining, and then finally it joins at the end. But now, when you look at these generated queries, I hope you have now a little bit better understanding why EF Core queries are so large, and this may actually be, in some cases, more optimal than the more simpler written SQL queries. And the reason why they do this is because most of the time, nobody will read this. As long as you're getting the right results, very few are going to look at the SQL query and say, okay, this is really horrible, unreadable, and stuff like that. And this is where you can use ChatGPT to then help you decipher what's going on. Here, I just said that this is a link table. All right. So what happens if we're doing the explicit includes? It's been a long day. So what happens here? We did implicit includes over here. So we didn't say we want to join those tables. But what we can say here is, please include those tables explicitly. And what that results is no change. There's absolutely no change. Now, there is one difference though. If I remove this part over here, tags, but I keep this then include, it will still do the join. So if you do explicit includes, it is your responsibility to keep it up to date. If you do implicit includes, it's EF Core's responsibility to keep up to date. And there's a good chances that EF Core is going to do a better job than you. Yes. So the question is if there's a good scenario to explicitly include. Yes, if you want to do safe changes on a complex data structure. First off, if you do select, you lose tracking. And second off, even if you manage to do somehow tracking and all of that stuff, you might end up writing, a really big mapping code. So include may save you time if you really need everything. All right. So now we are here joining tables in EF Core, and let's look at the data that we're getting. So here, apologies for a little bit smaller picture, but here we have the original results from SQL, and you can see we have all of the duplicates and stuff like that. Now, how many of you think that the author in EF Core in memory is going to appear 5 times? No hands. That's good because it doesn't happen. So what happens is the EF Core ignores all of those duplicates because it knows these IDs. And pro tip, if you remove all of the IDs in the query, EF Core is going to add them back. It just won't tell you that it's fetching those IDs because what it does, it actually looks up those IDs so that it understands which entities were already passed. And this is also why Entity Framework didn't support tables without IDs, because it wouldn't be able to properly map. And the other very important difference is this is like a list of entities where each is like a complex data structure and has like a graph structure. So it's a very different data representation than SQL. And that's very important when you start doing grouping and other things. But first off, you know that thing that I mentioned a few times, data duplication, and hey, this might actually be a problem sometimes. Well, let's look at this and let's say, what if the content individual post is 1 megabyte big? That could be a problem, right? Because we have 3 of them. So now instead of downloading 1 megabyte of content, we're downloading 3. Now imagine that this one is, I don't know, 5 megabyte. For whatever reason, the client might decide that it's going to have pictures in it as well. But we're not downloading just 5, we're now downloading 10 megabytes. And now this is becoming a problem. And how we solve this in SQL is we can just split it up into multiple queries. Simple, right? Well, how many of you think that it's going to be easy to write a mapping manually in EF Core, in .NET, and not spend an hour just, writing C# code? We have one hand. Well, what happens if this query doesn't actually give you the performance improvements that you thought it will? Well, this is another problem with it. You can easily write these queries, and you won't get data redundancy if you write them right. But writing manually, the mappings, imagine that you have 7 joins in it. You write the code, you write the mapping, and all of that stuff, and then you realize, oh, wait, this actually runs worse than the single query. What do you do now? Now you need to revert all of the work or rethink the whole thing. You're now in a position where, in a worse position than before, because before you thought that this could be the solution. But now it's like, okay, what do I do? Well, in EF Core, you can just do a split query, which automatically generates for you all of the queries and does the mapping for you behind the scenes. And if it does happen that you feel that this query is becoming slower than the original single query, you can just simply remove that line and you're back to where you were before. So it literally takes you 5 seconds to add that line and 5 seconds to remove that line. Now, some of you eagle eyes might notice this statement over here and say, hey, this is a bit redundant, we don't need it. true, but also doesn't have big performance impact. And there's a good chance that SQL Server might also realize that this is actually redundant and do the optimization for you. So in the end, it might not even matter. All right, so we have one line change of code. This can drastically improve performance. We had a leaderboard where we were fetching information from various points. And what happened was we needed to get roles for each user. And then within those roles, we had to get some additional information. Now, we were fetching data for 100 people. But that query ballooned into, I think it was 20,000 queries, 20,000 rows, because we had a lot of roles. And, you know, one-to-many relationships, all of the rows get duplicated because we have a lot of unique values on after the very last join. And that caused a lot of performance issues. And this worked incredibly. Like we had problems that it was actually timeouting, 30 seconds plus. This put it down to 500 milliseconds. So we got from 30 seconds to 500 milliseconds. That's how massive of a performance improvement you can get. Now, the thing is, in most of the cases, this is going to run you 20% slower, give or take, because it actually takes more time to download the results, to send the results to SQL Server than to actually deal with that overhead. So this is why you don't want to write all of these optimizations by hand, because they actually may not give you the benefits that you think that they might. It heavily depends on the relationships you have in your data, the scale of the data, as well as very specific scenarios. Like we didn't have that issue until we reached 200 people. Yeah, most cases it's a bit worse. So now let's look at another thing, SQL group by versus EF-core group by. So how many of you think they are identical? No hands. I might have primed you too much. So what happens with the SQL group by is SQL is a flat table. And because it's a flat table, the way SQL works is it wants you to summarize every single group. So here we have, for instance, an author that is grouped by country. We cannot just have a list of authors here. We need to summarize it. Now, the simplest summarization here would be count. On the other hand, and here we have the table, but on the other hand, EF-core and .NET, specifically .NET, because EF-core is just using a .NET feature, which is the group by. In .NET, we have complex structures, and it returns back groups that have list of data in it. So the difference here is I can just say group authors by country. And this is going to result in a very different query. It's going to result by simple select statement from authors, and it's going to order by country. It's not going to group by. The reason for that is the results I'm getting. I can now go for every single country and for every single author, and then print them out on the screen. That's very different data. The SQL group by is not similar to EF-core group by. They're very, very different. Oh, yeah. But we can make a SQL-like group by in EF-core. And it's very simple. We just have to add the select statement. We need to summarize the group. So as long as we don't have any lists here, that we are mapping into a flat row, we're going to get group by. So how many of you thought that this wasn't possible before in EF-core? We don't have any hands. How many of you have learned something new? Maybe better question. Okay, almost the whole room. That's good. All right, so I have shown you some querying, some joining, some grouping. Now I want to show you one of the things that we need to focus the most as EF-core developers, and that's indexing, because this is something that is underutilized. So with queries, it's quite misunderstood, but with indexing, I think, how many of you know that indexing is important? Whole room. How many of you actually use them? Oh, actually, how many of you are using it in EF-core? Okay, that's there. Okay, so everyone knows they're important. Everyone seems to be using them, but not in EF-core. All right, so hopefully that's going to change today. Now, I'm going to only show you how to use the indexing and how you can check if it is using indexes. But if you want to have more information about how everything works behind the scenes, Bryden did a really good talk about that and performance in general. Like, he actually showed you the reasons why you have to be careful with choosing indexes. So why do we want to have indexes? Performance. We want our application to run fast. And there is a point where you no longer can optimize your queries, no matter how much caching you add, no matter how much SQL engineering you do, you just bottleneck. You need to change the schema. You need to add indexes. And this is why indexes are so important. It basically allows you to keep the same data structure while also improving the performance. And the way it's improving the performance, if we look at the unclustered indexes, you can only have one. Usually it's sorted, and it defines how it's physically stored on the disk. So it's very important how you choose the clustered index. By default, EF-core uses the primary key. And usually that's good enough, but in some cases, you might want to choose to change that. We're not going to look into clustered index today, but I want you to at least be aware of them, that if you have a problem with the way the data is stored in the actual physical hard drive is the performance bottleneck, this is the index you want to look into. Now, the next one is unclustered index. Now, the great part of unclustered index is you can have multiple of them per table. And what is also interesting, how many of you knew that when you add a new unclustered index, you're basically getting a copy of the table based on how you define the index? We have like 5% hands. Yeah, very few people know it. And when I learned that, my mind exploded. Because now I'm like, oh, wait. So what that means is when I'm creating an unclustered index, I'm essentially making a copy of the table that is way smaller than the original. So when I don't need all of the other stuff from the original table, I can just query that index, which is really awesome. And if you want to see which index you're actually querying when you are doing a SQL query, here is the Azure Data Studio, and you enable here the enable actual plan. How many of you know about actual plans? About half the room. So some of you might know. So what we have here is over here, when we are doing the query, we are getting the query plan, and we are getting the information from where that data is coming from. By default, it's going to be the clustered index, which is our table. And this is where you know that no additional indexes were used to get the data. Now, how do we actually add indexes in EF-core? Well, the simplest thing here is when we do on-model creating, we can just say for the entity, do has index, and you add the country. And when we do select country from author, what you can see over here, now we have IX author country. Now what that means is it no longer now queries the original table. Now it queries directly just the index. And if you worry about what if index goes out of date and stuff like that, don't worry about it. SQL Server takes care of all of that. But if you have too many indexes, you might start to get performance issues when you insert and update data. So don't overdo it. Now, if we want to query, say, name, so we do name and country, what happens is, well, we are now querying the original, the actual table, right? Why that happens? Because that table has that data. If we wanted to use the index that we created for country, and we wanted to return name, and we wanted to bypass this optimization, we would need to join the index with the original table. But the original table already has the country data, right? Why would you do that? You would then need to do the same filtering, everything on the original table as well. It's inefficient. It's nonsensical. But it would make sense that you could do that as an index. So how do you do that? Well, if you just want to include that data, you don't want to index, you can use include properties. So what that means is that name is not indexed, but it is included in the index. So when I do select name, country from author, it now selects the IX author country. But what if you want to have it like a composite key? Well, you can use has index, and you create new, and you add the country and name, you add both of them. And now for the same query, we have select name country from author. But what you see here, it now says author, country, name, because now index also includes name. And how would you decide how to do the best indexes? Now, if you learn about databases, you have a lot of content on how to decide that. But if you're someone who heard indexes but never understood how to use them, when to use them, this is on Azure SQL, you can go to performance recommendation and you can look at the recommendations. Try not to use them right away, because if I say that you just use them, I will have a database engineer chasing me in the night, and I might not appear tomorrow. So don't use them right away. Maybe use ChatGPT or ask, tap someone who knows a little bit more about databases and say, hey, does that index for this schema make sense? Because this might actually give you, over-optimize things for just a given time. But then anything after that, that index actually may cause performance issues. And if you're not on Azure, there's actually a query that you can run that gives you similar results. I still have time. And you can get the query from our rules. We actually have a lot more rules on what to do if you have memory, CPU, pressures, lots of performance analysis and what you can do about them. Here I'm talking about how can EF core developers start tapping into that knowledge of the SQL engineers and DBAs. But there's also another thing coming along. There is this little thing called try Copilot with your SQL databases. Now, this is something that I haven't managed to play too much with, but there is a lot of rumors that this actually might be able to help you generate some indexes and optimize your databases. that it will allow you to ask questions about your database and then actually do performance improvements or give you suggestions on how to update your schema to be more efficient at fetching the data. And with that, we looked at how we do the logging, how we can integrate to get more useful telemetry in your application. We looked at how SQL gets generated in EF Core differently when we're adding more and more joins, and also why grouping is not the same in SQL and EF Core. And I also given you a short introduction into indexes. But the last thing that I want to give you is something that I actually got today at around 3 a.m., something like that. And I managed to squeeze in today. What if queries are fast in SSMS, but they are slow in production? Now, this is something that did actually happen to me, and I just couldn't figure it out. And I just thought, okay, this maybe I wasn't able to fully diagnose, because what was really weird about it was the SQL was running slower in production, the actual SQL query. But if I copied that SQL query into SSMS or Azure Data Store, it ran faster than the actual telemetry. And that didn't make sense because, there's no EF Core involved. Like, why, right? Now, there was one a Canadian that sent me saying, hey, hope you enjoy your NDC conference. It's like, there's something happened with EF Core 802 you might want to know. They added EF constant. You definitely want to have a look at it. And I was like, at 3 a.m., I was like, okay, fine, let's have a look. And then I was just like, wait a minute. That's the problem. Like, we're running this query over here, and it's fast. But then, for instance, over here, this query is slow. And the thing is, we get identical queries for these two. There's not much difference, not something that you could change and make it faster. But what they found is that the way they put that number 1000 in the query didn't allow SQL Server to do a very specific optimization. And as a result, it actually took it as a parameter, and it thought that that thing can constantly change. So it didn't optimize it as if that will never change. And what we're having here is almost like a runtime constant, right? We're only switching between two different numbers. So we don't actually need that dynamic way of looking at how many numbers we want to, how many rows we want to return. And what happened is, this is something that literally happened, I think, a week ago or something like that. Now we can do EF constants. And now we can tell SQL Server to say, hey, this doesn't change. This will be fixed. And this can have massive performance differences. So if you go into your telemetry, you get that, you look at it, and it's like, this takes 5 seconds, SQL Server, SQL query. I copy it and put it in SMS. And it's like 500 milliseconds. What gives? What? It's the same thing. How it can be different, right? This might be the reason. And I bashed my head for years. And now we know. Anyways, here are the resources. I hope you enjoyed the talk. We're going to have, if you want to have rewards for 800 points, you can come to our booth. And with that, thank you. We have 5 minutes for questions. Yeah.
have a unique constraint on your index. So those edge cases where the race conditions of expecting two records to try and be inserted at once. So SQL throws the unique constraint error. Is there any workaround to not get Entity Framework to log that as an exception? So say you want to handle it in your code, and the Entity Framework by default will just log that as a critical exception, even though it's in a try catch.
So I had a similar question for a different talk 2 weeks ago. I haven't really specifically looked at. It's on my to-do list. But I remember that when EF Core 3.1 came out, even 3.0, there were global configurations for EF Core for that DB context. And one of those is enabling and disabling warnings. I tried to look up really quickly for the answer, and I wasn't able to quite find it. But I know that these settings are still there. Just Microsoft doesn't really want you to use them unless you really need it. So long story short, it probably exists, but needs to be looked up.
Okay, thanks.
Any other questions? We have one front.
So you mentioned that there is copilots for databases.
Yes.
Like just to scan maybe some indexes missing. Have you tried Copilot in Visual Studio to see if it can, from your code, see? Because if you do in code first, you don't want to throw any indexes through just SQL. You want it all in your C#. So can GitHub Copilot in Visual Studio identify if you're missing some indexes and just add them automatically in your model?
So I use ChatGPT 4 with the prompt where I say you're an expert in .NET, EF Core, and SQL Server, where I was able to put in link statements and SQL statements, and I could translate from one another, have explanations, how one got into another. And I even got to a point where I was able to take a raw SQL and get me a EF Core query out of it. There's quite a few cases where it didn't generate it correctly, but then I tried 3 times, 5 times, and the 5th time actually generated it correctly, because it sometimes tries to use features that don't exist. And I was successful. With GitHub Copilot, I didn't have that much success. I just usually use ChatGPT for most of the stuff that I do when I'm dealing with SQL and Link.
My question is to do with hasIndex function. In EF Core, do we have to create this index manually, or does EF Core create it for you?
That's created for you. So if we go a little, this one, for instance, that index is created for you. So you just, if you have migration enabled, just create a new migration. If you don't have, you just do ensure created, and you'll have that. You don't have to worry about it.
Okay. Thank you.
Yeah, and my original talk actually had so much content that it took 10, basically when I did one part of it, it took me 2 hours, and then I was just I'm not even 5th across. And then I realized that half of the people didn't understand half of the things that I showed today. And then I realized, hey, these are the things that most people know, but they actually never think about. So how many of you people here knew the things that I showed you, but you never thought of what would be the consequence of that, or how it actually impacts things? So we have about half of the room. Yeah, and that's the purpose of this talk, is basically take a step back before we go into advanced stuff in SQL and EF Core and say, hey, do you actually, I know that you know all of this stuff, but do you actually know? Do you know how that impacts? And hopefully with that, I'm going to then build up a new talk that will start to talk about more advanced stuff. because I literally tried to go through all of the link statements, all of them, and try to figure out which one are working in EF Core and which are not, because the documentation doesn't tell you. And I have found things like group join, which I was just like, what is group join? And I found some things that I was just like, first off, I didn't know that it existed, and second off, why? And third off, that's actually awesome. So hopefully that's going to be my next talk. And with that, we have any questions? Sorry.
Sorry. Like if there is already an index which like has a country and name, will it duplicate or?
So if you define it in EF Core, it's
database already.
Yeah. So if it's in the database, because there's the thing, if you scaffold the database, then that index will already be in the EF Core schema. It will be aware of it, right? But if you somehow have that index without database scaffolding or things like that, it may actually generate a migration that will fail because it might name the index the same. Or you might have two the same indexes with different names.
Thank you.
All right. Let's have some break and enjoy the conference.
Thanks, Ego.